Hi, welcome to the Linux channel. See, last week while having a session with my student, there came a discussion about registering protocols, how it happens within the Linux kernel space. As you know, we are discussing about L3 and L2 protocols, and even transport layer as a part of L2 L3 stack. So I was just doing a walkthrough, and then I find similar questions being asked by some of the viewers in the past as well. I got few emails regarding that, how I can design and develop my own protocol and stuff like that. And these things I have covered in the past about the basics of architecting your own protocol. You can go to the channel, and you can do a basic Google search, but in my case I can do a very quick search, network protocol, something like this. And you can see there one episode I have done, 339. It's about how you can architect a protocol. So this is a basic step towards any beginner, how you can architect a protocol, how you can write the stack, how you can write the parsers and data structures and stuff. So this is more than enough. I have done some basic arithmetic calculation. You can just send some variables and it will add, do something, and it will return the answers back. So it's a very simple basic example, but in this video I am going to cover about the kernel data structures. But in this case it's specifically about lower level protocols. Okay, upper level protocols, most of them are in user space. So before that, let me copy this link and keep it over here, so that I can attach this links in the video description, so that you can have a look. So this is one video you can refer if you are interested about this topic. And another video I can recommend is this kernel and user space with respect to network protocol. It is about user kernel space. Yeah, I'm not able to get. Another way I can do is I can go to the channel and browse through videos, and if I find that, I can add this video link as well in the description, because this video is important, where you can quickly understand based on the layers. You can determine where it will be implemented and for what reason. Okay, if it is low level layers, network layers, protocol layers, then it will be in the kernel space. If it is high level application protocols, those will be in the user space. And I have in depth talked about it, why so and stuff like that. So you can have a look. Let me search and add it in the video description. So sometime couple of years ago I have done that video and posted. So yeah, Linux kernel space modules, etc, ring buffers. So somewhere here, in fact I have sent this video suggestion to a viewer as well for a comment, or in a mail. I'm not sure. Let me check my comments. If I find, I can just pull it out. Yeah, you can see there, this is the comment. You can see there, I think so, network stack design, user space versus kernel space. So this is what it is. It is 266, and we should able to find that video somewhere here. 266. Usually my video numbers are hexadecimal, so it is hexadecimal 266. So let me go up, 22, 22A, 266. No, it is somewhere maybe old video or something. So you can see 266 and if I do a search, you can see there it comes here, and by the look of its banner, I can definitely say this is quite old, and I can see its date of posting, it is quite old. So I recommend you to watch this video as well. So let me copy its link and add this through in video description along with this current episode. So the current episode is all about how this protocol registration happens, and if needed I may do an add-on video later. Okay, I may cover some basics and I may do some add-on video later, so that we can explore this in depth. So this is very useful if you are doing some PhD or some R&D and you want to do some add-on to existing IPv4 stack or something like this. Okay, so let's start with this file net IPv4 afinet.c, and you remember, if you do some socket programming, you will be adding this as a family and stuff. So let's start with this file. So we are in the kernel source, as I always capture. We can go quickly in bootlin and open the kernel source, or you can do download your kernel source and you can do your regular way. You can do a code walk of your kernel source. You can do either way. So I find it always this is comfortable. So you can see there we are inside this, and you can see here this is where the protocol registration happens when it comes to this transport layer protocols. And let's assume you want to add some transport layer protocol on top of IPv4, something like that. So you can refer some basic data structures. The whole intent of this video is to introduce these couple of fundamental data structures. So if you go here, you can see there somewhere you have this inet init. Okay, so this is there, and let me just scroll. See, this is at the line number 1931, this inet init. So let me just copy find, and we are at this line, and we go a little bit above and see the flow. So you have this, and you have this implementation of socket, etc., the intro, and after that this file starts. Okay, so as you go below, you can see it is finally about this release and various other APIs, and finally it comes to this API. Okay, inet init, and which is that line number inet init, line number 1931. So you can see there. So here you can see proto register, and there is this TCP prot, which is a pre-populated data structure. We get it here. In same way UDP prot and ping and raw prot and stuff like that. So you can see this is one place it is getting added up, and if you check this proto register, okay, what is this API for which data structure? Okay, so if you click this, you can see here you have this sock.c and sock.h. We can try both of them, whichever is helpful for us. So if you click the sock.h, you can see its prototype is this function, this thing, and you can see it is picking up this data structure, which is struct proto. And if you go up a little bit, you have this data structure, which is this proto, and as you can see it has all that other references so that it can work. Okay, you see, and all its other APIs associated with this data structure. You have the send message, receive message, stuff like that, which if you remember when you do socket calls you have this bind API and all those. So hopefully when you do in user space, this takes care of that association, and possibly this will be linked to that on the kernel side of it. So this is my guess. Okay, hence I am saying this video I may later do one add-on, and if I find something more interesting I may actually do a second episode on the same. But before that, if you are very new in some of these things, and that is why I am suggesting, you can go back and refer my old videos. This is really old. I recommend you to watch this, and you will get some idea. Okay, so by the look of it, you can see there this has these APIs, and this is the context. And what about this TCP proto, what is this data structure? So we click and we see where it is populated. So if you see here, it is populated inside this TCP underscore IPv4.c as a part of IPv4 stack. Okay, so you can see there the name is TCP blah blah blah, and these are various TCP related APIs. And similarly you have this UDP prot, and if you open, it is inside this file which is udp.c. Within that IPv4 stack of kernel source. So you can see that this is this UDP, and again this has its corresponding APIs. For example, we see this IOCTL, you see this UDP IOCTL versus here TCP IOCTL. Same way destroy UDP destroy sock, in this case it is destroy TCP v4 destroy sock. So you have all this APIs which are populated, which corresponds to this data structure, which is this sock this struct proto data structure, which contains all this callback APIs. Okay, so you can see there. So this is one aspect of protocol registration, as you can see here. The other aspect of protocol is within the kernel source itself. So if you see, if you come down, you have again this inet add protocol, ICMP protocol, blah blah blah, and you have all this APIs, and also this populated data structure which is associated with this different API. Okay, so you can open one of this instance. Let's you can open one of this data structure instance and check its definition of this API. You see this inet add protocol, it is in protocol.h versus this is in sock.h. Okay, the other one which is this proto. Okay, so this is in protocol.h, and we open this .h file. We can see there inet add protocol, inet delete protocol, and this is taking a different data structure called net protocol, versus there it is taking struct proto versus here struct net protocol. So if you go up somewhere, you should able to find its data structure definition of that. You can see the net protocol, and this is what it takes. So you go back here, and this net protocol, it is also taking this IP proto TCP and stuff, which you have this the IP header should have this protocol number, which is for the TCP 6, for the UDP it is 17 and stuff like that. So you can click this and you will find that definition in this UAPI Linux in.h, and you open, it will be some sort of enumerated or hash defined data structure. In this case it is an enumerated data structure, and you can see there TCP 6 and stuff. So this is the regular stuff whenever you access any socket APIs or any such things you do in regular day-to-day stuff. Okay, so you can see this is where it is defined. Okay, so that they are passing, and they are passing to this API, which is this inet add protocol. And if you go back, we came over here, inet add protocol, which is taking this unsigned char number and this data structure. So we have seen that struct data structure, and we can also see this TCP protocol, the populated data structure. So click that and go here, it is in the same file af.inet.c. we are in the same file. You can see there we are in the same file, but at a different line, which is 1730. So click this line, and you can see their net protocol, and they are just populating this, and this they are passing it to the data structure, and this contains this handler TCP v4 receive, and if it is error, then this is what, and let's click this, what this contains. Okay, so let's open this. So this is in tcp.h and tcp IPv4.c. so we can open this one. Possibly it is defined over here, and this is that API which is linked to this callback handler. So you can see there. So this is what it is. We can also click this .h file, and we have this definition of this API. So this is what it is. So if you are interested, you can have a look. And interestingly, if you see here, there is another transport layer protocol called SCTP. In fact, long back, I got a student who is she is doing her masters. I'm saying about more than a decade ago. Okay. She is doing her masters and she is doing some research on SCTP stack. The interesting aspect of SCTP is it combines both TCP and UDP features, so that you get both connection oriented and connectionless features within the same transport layer. For some reason it never got popular. There was some rumor at that point of time that TCP will be replaced by SCTP and the internet may use SCTP protocol, but that never happened. Okay, so in that way, if you see, it is not, SCTP is not registered here, which means it is registered somewhere laterally. Okay, which means it is done somewhere later, which is not a part of the standard AFINET.c. So which is what today I was having a look, and then I thought, why don't I shoot this video, because also this is a frequently asked question both from my students and also from the viewers. Every time I get a mail about something like that, especially I get a mail from very new beginners who are into network software development and stuff like that, but this is meant for somebody who is intermediate, not for a complete beginner who is just starting his journey. Okay, so that's what this is, a topic meant for a little bit advanced developer who is well versed with networking basics and also programming basics and kernel basics and kernel network stack basics, and they want to go a bit deeper and want to explore things like this. And also somebody who is doing some research, maybe you are a PhD holder doing something, maybe you want to invent your own protocol for some reason, put it on top of IP stack and do some experimentation, then this is especially a video meant for guys like you. Okay, so the SCTP stuff, somewhere I just added this link. Let's just open this link and go through the same. See, in the case of SCTP, somewhere they are doing this. You can see their INET add protocol, and they are adding it somewhere in this API within this SCTP part. So you can see their add protocol, whatever is happening in AFINET.c, they are doing lateral, which means later in the case of SCTP. Okay, which is this add protocol. And also we can check what about the other API. Okay, what about the other API call, which is this proto register. So let's check, even this is getting called in the file proto register. You can see their SCTP proto init, and in that case they are doing that. And possibly this may be registered more like a module, unlike the TCP part. So let's see if it has any module this thing. So you can see there it is initialized like a module, versus in the case of TCP UDP it is not done like a module. I mean to say, it is not done like module init and exit. It just happens as a part of core IPv4 network stack, versus in the case of SCTP it is just done in a way that it is not a part of AFINET, means it is not a standard feature, but you can initialize this module and then it can add as a functionality in a lateral situation. So that's what is happening. Similar way, if you want to architect something, I recommend don't waste your time with UDP and TCP way, unless until if you have an objective of putting very much as a part of core functionality and compiling the whole kernel. But if you are intended to do like a separate add-on module and things like that, I still recommend you can also have a look on this SCTP stack as well. So do a comparison between this approach and that approach, and first try to understand, and then get the significance, and then you can do the whole porting of things has to be registered as per your protocol and your protocol functionality, and then you can do some R&D. And of course you need to work on other aspects as well and user aspects as well, because these are protocols, these are like service protocols. What I meant service protocols are, these are not an application layer protocol which is just transferring some user data. This is actually a service protocol which is a service enabler to carry that application protocols. It's just a term I'm just defining to make it simpler. So we can consider these are like base service protocols. So when you do that, you can take care of these aspects as well. So you can see that, hence you can see they are doing in this way. So there is a module init and exit. So I don't think so you'll find anything in AFINET.c. Let's check any module init. Module init exit. You won't find anything in that AFINET because it's very much part of kernel network stack. So if you enable that, when you compile the kernel, it comes as a base functionality. But in the case of SCTP, it's not like that. It's been added as an extra add-on functionality. As I said, at that point of time, I'm talking literally about 2006, 2007 era. Okay, so that's the time I got a student who is doing some master's degree, who wants to do some research on this SCTP stack. So hence you take this as a reference, compare the standard way, which is TCP, UDP and ICMP and stuff like that, and compare it with SCTP. In fact, if you go here, you have even that raw socket stuff also. Raw, when it comes to this raw socket, even they have done this thing for raw socket as well. And you can see this, anything fails, you have all this go to, so it will do a go to and it will go down. See, if there is anything which is failing, then there is this go to and it is unregistering that registration to clear up all that allocated resources. Okay, so this is what. So with this, I would like to conclude this episode. Okay, what I am going to do is I am going to go through this further, and I may do a quick add-on. If I find something which is more interesting and relevant, I'm going to attach most of these links, whatever I opened in the video description, so that you can go through, and if you have anything to share, if you have done any work, perhaps you can share, and perhaps I can do a walkthrough for the viewers. Or if you have any queries, you can discuss in mail, or if it is a very small query, then you can discuss in YouTube comments as well. So hope you enjoy this video. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.